In this video, we'll discuss several pre-installation checks you should make prior to installing a PyData archive, as well as specific requirements related to creating a Pi collective. After installing the PyData archive, we'll verify that we can successfully connect to it and even see some test data values. At the end of this lesson, we'll have a fully functional PyData archive installed on our PyServ2 machine. This will eventually take on the role of a secondary member in our Pi collective, which we'll create later in this course. At this point, we've finished with the big picture Pi system planning, including sizing our servers with the hardware sizing spreadsheet, as well as deciding to implement both PyData archive high availability, as well as interface failover. We're almost ready to jump onto our machines and start the installations. But before that, let's verify that our server passes these PyData archive pre-installation checks. One of the first prompts during the installation will ask for the location of a Pi server license file. This file contains site-specific parameters like which Pi system applications can run on the PyData archive and maximum Pi point count. Typically, the process involves creating a machine signature file, or MSF, on the PyData archive node, and then submitting it online at OSIsoft's tech support site. What you get in return is a zip file with the Pi server license, or pylicense.dat, included. There's another license file included, the temporary Pi server license. This file is to be used for any soon-to-be secondary Pi collective members. During the Pi collective formation, all license files belonging to secondary members are overwritten, so a temporary Pi server license is sufficient for these PyData archives. So remember, you don't need to generate a separate computer-specific MSF for secondary members of a Pi collective. We can assume all of these steps have been completed since a PyData archive has already been installed on the PyServ1 machine. The Pi server license for PyServ2 can be found on the desktop. We also need to make sure that our Pi server license allows for the formation of a Pi collective, or stated another way, how many secondary Pi collective members are allowed, if any at all. We'll check this when we get on the machines. Next, a prerequisite of a PyData archive installation is the presence of a PyAF server. Since PyServ1 already has a PyData archive installed, we can assume that a PyAF server already exists. It happens to be sitting on PyServ1 itself. As with any installation, it's important to have administrator privileges on the machine you're installing on. Otherwise, you may run into security issues with trying to install new programs. Our account does have admin privileges. Time zones play a big role in the Pi system. To ensure that time zone differences are converted properly when users in different regions access data, it's important that the time zone on the PyData archive is set correctly. To keep things simple, our virtual machines don't have a specific time zone, but rather go with the Coordinated Universal Time, or UTC. Lastly, a simple tip. Make sure to regularly update Windows, both for patching security holes and having the latest Windows components. Let's assume this applies to us as well. Although these aren't every single verification step, know that a comprehensive list can be found on the PyData Archive 2015 Installation and Upgrade Guide found on OSIsoft's tech support site. Here's a list of the general steps involved in a PyData archive installation. Beyond this, you will also notice that there are plenty of other pieces installed along with the PyData archive, including some default Pi interfaces and a client tool called Pi System Management Tools, or PySMT. At the very end, we'll complete several post-installation verifications. One note about the location of PyData archive files. On PyServ2, there are 5 hard drives, C, D, E, F, and G. This D drive We won't be using it for any Pi system related files, so feel free to just ignore it. For binary files, we'll place them in their default location, C program files Pi. Archive files, which includes both historical and future data, will go into E drive, and event queues inside the F drive. Since the PyData Archive installation includes not only the PyData Archive itself, but also a handful of other programs, like default Pi interfaces, they'll go in separate folders labeled PyPC. There are 32-bit and 64-bit versions of this folder, which will be placed with the PyData Archive binaries on the C drive. One last thing I'll mention is archive sizing. The hardware sizing spreadsheet gave recommended sizes for Pi archives, but here's how the calculations are actually made. Depending on the total number of licensed points, a Pi archive size is determined. And also, in addition, the archive size is dependent on the computer's physical memory, as shown here. But luckily, on newer versions of the PyData archive, these calculations are completed for you and displayed during the installation process. At that point, we'll just accept the defaults when asked. We're now ready to get on the machines. I mentioned earlier that I double-checked to make sure that our Pi server license allows for the creation of a Pi collective. I'll jump onto PyServe 1 now. We'll take a look at this tool, Pi System Management Tools, a bit later, but here I've opened up license details and can confirm that secondary Pi collective members are allowed. We can have as many as 99 secondary members if we wished. Okay, great. Let's head on over to PyServe 2. Alright, now we're on PyServe 2. Here on the desktop, there is a software kits folder, and inside you can find all of the installation kits, as well as a PyServer license file. Inside this folder, let's begin the installation by clicking on PyData Archive 2015. And here it's asking for a location to extract the individual installation pieces, so I'll place it somewhere convenient in case I need them again at a later time. And I'll choose the desktop as my location and give the folder a name, extracted files. Alright, so the files have been all extracted and the installation begins on this screen. Here is a list of all the components included in the installation. Some will be skipped if they are incompatible, like 32 or 64-bit only pieces, or if they're already installed on the machine. Alright, so we can press OK. Here, we're asked for the location of the Pi server license file. Now, we know it's on the desktop, specifically in the software kits folder here. So let's go and browse for that folder. Okay, and here is our PyLicense.dat. All right. At the bottom, you'll notice that it mentions a machine signature file was created in the documents folder. I mentioned these MSFs during the Pi server license section. Here is where you can obtain the MSF that you'll then upload to the tech support site in order to download a Pi server license file. And of course, we can skip this since we already have a Pi license. It also tells us what our maximum point count is, 5,000. Okay, we can click Next. On this screen, it asks for the computer name that has the PyAF server installed. Remember, this is a prerequisite for PyData Archive installations. Our PyAF server is installed on PyServ1, so let's type that in here now. And then click Next. Here, we specify where our PyData archive binary files and those PyPC related files go. We'll leave them at their default locations, which are just all on the C drive. Now, this screen is where we'll deviate from the defaults a little bit. We have a separate drive for PyArchives, namely the E drive. So we'll switch that for the historical and future archives. And it's as simple as just changing the letter here. All right, so change that to E. Event queue files will also be on a separate drive, which will be F. And to be more consistent with the archive files, let's have it be just Py and then Q. In the Modify Archive Settings link, we can see what default sizes are chosen for our PyData archive. Remember, archive size are calculated based on the number of licensed Py points as well as the computer's physical memory. We'll take the defaults on all of these and click Next. For the rest of the installation, there isn't much more customization involved. The PyData archive portion is complete, so we can just read what gets presented and click Next or OK. In this screen, you can see the individual components of the PyData archive starting up one by one. Alright, we're finished. In this dialog box, you can see the list of different components that were included in the installation. So the PyData archive has been completely installed. Let's move on to some post-installation checks, including making sure we can connect to the PyData archive and that the default Py points are collecting data. One step that you would also normally do now is to download a file that the PyData archive uses to account for past transitions for daylight savings time. By default, only the current daylight savings time transitions are known. Depending on the time zone that the PyData archive node is in, there are different localhost.tz files that you can download from the OSIsoft tech support site. This ensures that all historical daylight savings time transitions are taken into consideration by the PyData archive. Since we're using a daylight savings time agnostic time zone, namely the UTC, we don't need to worry about any of this. Alright, next let's open up the PySTK utility. That can be found by clicking on Start and then STK. Alright, first option there. Here, we can test the connection to the PyData archive. Of course, we're on the actual machine hosting the PyData archive, so a successful connection is almost always expected right from the start. But this tool can be useful to check for connections on remote nodes, especially. We'll click on Connections and check the box next to the name of the PyData archive node. Great. We can also see other tidbits, like if we're using a trust, the IP address of the PyData archive node, its version, and more. Besides the PySTK, which is a type of protocol between client nodes and the PyData archive, there is also the PyAPI protocol. Put simply, many current Py interfaces utilize this PyAPI protocol to communicate with the PyData archive. To test PyAPI, let's open a command prompt. All right, let's start, and then command prompt, and navigate to a folder C program files x86 PyPC bin. Now, it's a little cumbersome to type that in all at once, but here is the location specifically. All right. And instead of navigating to this location literally, we can make use of Windows environmental variables that we can use to get there faster, namely %pyhome%. So I'll demonstrate here. And we'll change the directory to %pyhome%, and then it's specifically the bin folder. Okay, that takes us right to C program files x86 PyPC bin. In this folder is a tool called API Snap, which shown here is represented by that program. So we can run API Snap by typing in API Snap and pressing enter. When launching this program, it'll attempt to make a PyAPI call to the PyData archive. Once you see a successful connection like here, you'll be allowed to further interact with the PyData archive if you want. You can type in PyPoint names and retrieve their values. So one example default PyPoint that exists is called sinusoid. Press enter. And we see some values that we get back. So we can make both PySDK and PyAPI calls to the PyData archive. Now, let's open up Py System Management Tools. So I'll exit out of what we have here and start Py System Management Tools. Okay. Here, let's take a look at a handful of default PyPoints, like the sinusoid we just saw. In the data category, click on current values, and then let's click the tag search icon here. But first, we'll have to select which PyData archive to connect to, and then here is the tag search icon. To search for these PyPoints, you can substitute the star symbol under point source with the letter R, and then click search. We see a list of returned results, these 5 PyPoints. Click on select all, and then OK. These are all the most recent values for these PyPoints. And you can see that the timestamps are relatively recent. Right now it's 4:13, and a lot of these are pretty close to 4 or at 4:13. We can click refresh to see any updated timestamps and values if there are any, as well as pressing play to see them update in real time. Next, in operation, there is AF-link. This is important on single standalone PyData archives and primary PyCollective members. The AF-link subsystem keeps the PyData archive's what's called module database synced with the PyAF server. The module database, or MDB shown here, is considered a legacy feature of the Py server, as much of its functionality has been implemented and improved within the PyAF server. AF-link first migrates this MDB structure over to PyAF, and then also continually keeps them in sync. There are some PySystem tools like PyAdvanced Calculation Engine that can read only the MDB and not the PyAF server. So the MDB isn't completely out of the PySystem big picture just yet. In PyCollectives, only the MDB on the primary member is synced with PyAF. So we don't need to concern ourselves with this on secondary members. Next, on the Archives tab, we get a list of all of our Py archives. You can see the location of Py archives shown here, as well as their size. Remember, we specified this during the installation process. Lastly, the tuning parameters section down here is where you can configure a PyData archive on a specific machine basis. In other words, these settings apply to just the PyData archive on PyServe2. These settings are never synced between PyCollective members. For example, here is the location for Pi archives. PyCollective members could easily have different number of drives and different letters for each drive, so these types of settings need to be specific to just its own machine. Alright, and that wraps up the PyData archive installation. After confirming several pre-installation checks, we went ahead with our first installation, namely for the PyData archive. Afterwards, we made successful connections via the PySDK and PyAPI protocols. Also, we looked at PySMT to verify that the default Pi points were updating, as well as learn about what PySMT allows you to view and customize. We'll next look into how to give remote Pi system applications access to the PyData archive.